So we're going to practice. And we're going to review real quick what a tangent line is and what a secant line is. So hang on, I have to do my little pin. All right, so we have a tangent line is a line that has 1 point in common with a curve. It's a line that has 1 point in common with the curve. So when you're looking at this, you see tangent line 1 is purple, okay? And you see tangent line 2 is also purple. But if you'll notice, if you draw those lines, this has 1 point in common with the blue curve. Okay, this also has 1 point in common with the blue curve. So if we can find the slope of the tangent line, we will by default find the slope or find the formula for instantaneous rate of change, because the slope of tangent line number 1 is also the same value as the instantaneous rate of change at 5 on the blue curve. So they're the same thing. Okay. So if I want to find the slopes of the tangent line, so this is just a practice one. If I want to use this point at 3, and so you can kind of see where I'm going here. If I want to find where t equals 3, then what is the estimated rate of change? Okay, so I know going from this point to this point, okay, is going to allow me to find that slope. So what did I do? I went up 7.5 and I went over, sorry, that's a 5. And I went over 5, okay? I went up 7.5 and I went over 5. So do your vertical change over your horizontal change. And when I do that math, I get 5 into 7.5 is what? So I'm not even going to try this in my head right now, sorry. I know it's easy, but I'm just not. So I have, I'm operating on no sleep again. All right, so 1.5. Okay, so what does that mean? That means that the average rate of change, okay, for your infant's weight when T is 3 months old is 1.5 pounds per month. Okay, what about when it's 18 months old? So this time, do you see how this is kind of leveling out? Okay, so in other words, you don't want the kid to keep growing forever, otherwise it's going to be millions of pounds big. All right, so if I want to estimate it again, my vertical change is 3.5 over a horizontal change of 6. And when I do that math, I end up with 0.58. Okay, 0.583 repeating. Okay, and it says round it to 1 decimal place as needed, so 0.6. So that should make sense. When a kid is born, it's going to get bigger faster than as the kid ages. Okay, so what is your average rate of change in the infant's weight over the first year after birth? So now we have this value right here, which is going to be the first year is how many months? So that's going to be 12 months over what's the change. So we go from 0 to 22.5. Okay, so we have 22.5 divided by 12 is about 2 pounds a month. Okay, 1.875. So about 2 pounds a month. That's what we're looking at. So I'm going to pause this and pull up the new problem. All right, so you can do problem number 2. When I look at problem number 3, what I'm going to use is I'm going to apply the difference quotient. Okay, and there's a step 1, step 2, step 3, step 4. And so basically what it says is this. Step 1, wherever there's an x, I'm going to put an x plus h. Well, what is my formula? My formula is a negative 6. Okay, my formula is a negative 6. Is a negative 16. I want black. My formula is a negative 16. There's not an x there, which means when I trash my x and put in an x plus h, there's nothing to change. Okay, so I'm going to end up with a negative 16 there. I can't change anything because there's no x to change. For step 2, I'm going to take my original minus I'm sorry, my original and subtract it off of f of x plus h. Well, again, I couldn't change anything. So when I do this math, I end up with a 0, okay? Because all you're doing is working with the numerator at this point. So this one, I want to take 0, or I want to take whatever I just found in the last step and divide it by 0. Well, what is 0 over h? It's 0. And so what do I get for an answer? Well, the limit as h approaches 0, or this difference quotient, is going to be 0. So what on God's green earth does that mean? If I graph this, f of x equals negative 16 is the same thing as y equals negative 16, which means it's a horizontal line that slices through the y-axis at 0. Horizontal line that slices through the y-axis at negative 16. But what is the slope of a horizontal line? The slope of a horizontal line is 0. So you just use calculus to show me that the slope of the horizontal line is 0. So on number 4, which I have to jump around and do gymnastics to get to, on number 4, we're going to do the same thing, but this time we're going to have an x to do. All right, so for number 4, we actually have an x to use. And so what does this mean? For step 1, we're going to find the slope of the tangent line to the graph of the given function at any point. In other words, instead of m equals y2 minus y1 over x2 minus x1, we're going to find a formula for slope. Okay? The formula for slope on the last one was 0. Well, now what do we have? Wherever there's an x, I'm going to put an x plus h. So that gives me 4 minus 8 times x plus h. Okay? Now simplify it, okay? So that gives me a 4 minus 8x minus 8h. So I just distributed the negative 8. So that is my first step. So I've got 4 minus 8x, that's an x, minus 8h, okay? The second step says subtract off the original function. So I've done this part. Now I need to subtract off the original function. So I'm going to subtract 4 minus 8x. Well, what do I know how to do? I can distribute that negative. So now I've got a 4 minus 8x minus 8h minus 4 plus 8x. Okay, so you should see that some stuff is going to start reducing out. So if I look, let's go back to red for a second, positive 8x and negative 8x, negative 4 and positive 4 is going to leave you with a negative 8h. So this whole thing reduces to a negative 8h. So what is step 3? Step 3 says take the answer from the previous step and divide by h. So let's go back to using a black pen. So I've got negative 8h over h. Well, that means your h is reduced. So what are you left with? I'm left with a negative 8. So the last step says take the limit as h approaches 0. There is no h, so you can't take the limit. The limit is a constant of negative 8. So what does that mean? Once again, you have used calculus to prove that the slope of that line is negative 8. Okay? The slope of that line is negative 8. So it's important to realize that just because you're doing calculus doesn't mean that algebra stops working. Okay? So if I had asked you to find the equation or the formula for slope of the tangent line, well, your slope is negative 8 because it's a line. Okay? So let's pause and do another one. All right. So now we've got some stuff going on, because now we're out of algebra world. In other words, when we're dealing with slope, we only deal with straight lines. Now I'm dealing with a parabola, so it's a negative x squared. That tells you it's a parabola, which is not a straight line. So now we're getting into the calculus of this mess. Okay, now we're finding out that we can't just use m equals y2 minus y1 over x2 minus x1. So the first thing I'm going to do is wherever there's an x, I'm going to put an x plus h. So I've got a negative x squared, so negative x plus h squared plus 6 times x plus h. So again, wherever you have an x, trash it and put x plus h. Okay, so it was negative x squared plus 6x. So now I can do math. So when I expand the x plus h, remember that that is not x squared plus h squared. You're going to have to FOIL that out. And I'm going to have to pause because the plumber's here. All right, so remember that you're going to FOIL this thing. So when I FOIL it, oh no, I don't know how this works. Okay, there it is. Trash. All right, so when I FOIL this, remember it's going to be first, outer, inner, last. So don't distribute that negative yet. So what that's going to give me is an x squared plus 2xh plus h squared plus 6x plus 6h. Okay? And then I'm going to distribute my negative. So now I got a negative x squared minus 2xh minus h squared plus 6x plus 6h. Remember, this is an h. Okay, so now I'm going to combine like terms. So foiling, hang on just a second. Foiling is x squared plus an xh plus another xh plus h squared. So that's where the 2xh came from. All right, so when I go through this negative x squared, wait, ooh, shoot, undo. I don't know how to undo. Hang on, I just bought this stupid thing. All right, so this is a negative x squared still. I'm sorry, I was going to combine like terms, but we don't have any yet. So your top line, your first line, is a negative x squared minus a 2xh minus an h squared plus a 6x plus a 6h. Okay, so now what I want to do for my second line is go ahead and subtract off my original function, which is a negative, and then what was my original function? Negative x squared plus 6x. Okay, so this is where I start combining like terms. So at this point, I have a negative x squared minus a 2xh minus an h squared plus 6x plus 6h plus x squared, and then minus 6x. So what can I now reduce? That's what I was trying to do too early a while ago. All right, so I got a plus x squared and negative x squared. I got a minus 6x and a positive 6x. So what I'm left with is going to be a negative 2xh and a negative h squared and a positive 6h and everything else reduced out. Okay, so at this point, what am I supposed to do next? I'm supposed to divide by h, and I'm going to, hang on, still learning. I'm going to erase and erase I said, okay, and erase all this mess. Okay, so that leaves me with that mess right there, okay? So can you reduce? Absolutely. At this point, everything that you have should have an h in it. And now I'm going to kill an h out of everything. So that'll leave me with a negative 2x minus h squared over h is minus h, and then a plus 6x over h is a plus 6. Okay, and this is where the limit comes in. So now that I've reduced all that out, let's erase this real quick. All right, so now that I've reduced all that out, I end up with the limit as, so the limit as h approaches 0 of negative 2x minus h plus 6. So anywhere that there's an h, you put a 0. So this is going to go away because it's a 0. So what's your final answer? Negative 2x plus 6. So what did you just figure out? You just figured out the formula for slope for any point on the curve. It's tangent line. Or you figured out the formula for instantaneous rate of change. That is what you just figured out. Okay, so that is that one, and then we'll come back for the next one.